Hello everyone, welcome back to my channel Codebook. So today we are solving one of the most classical asked problem in coding interviews, Maximum Sum Subarray. This is also known as Kadane's algorithm. So we'll have a look to the problem statement. Here we have given an integer array and we have to find the contiguous subarray which has the largest sum. So we have to return the sum of that subarray. So here there is an example given to us. This is array and the middle of this array is the subarray. That subarray contains the sum which is the largest in the whole array. Simple enough to understand, right? So let's have a look to first brute force approach. First thing that comes to the mind, let me check with every possible subarray. Have a look to the brute force approach. First thing that comes to our mind, so we can use the two loops and I as the start and j as the end of this each subarray. So we can calculate the sum of every subarray and keep track of the maximum. I mean, we can start with every subarray. This is also a subarray. This is also a subarray. If you start from this, this is also a subarray. So we can check each and every subarray sum. And this whole array is also a subarray. This one element is also a subarray. So we can check with every element by tracking the two index. So this will give us the complexity is time complexity will be big of n square or maybe n cube if array is will be space complexity is big of n square. So now this works, but for the large input this is going to time out. So if we have 10 to the power 5 elements in the array, so 10 to the power 10 operations will be. That's not acceptable. So we need to something better. So that's why there is in Kadane's algorithm. Let's have a look for that algorithm. Where Kadane's algorithm comes in, and it's very beautiful in its simplicity. The core idea of this algorithm is at every index, you make a very greedy choice. Either extend the current subarray or start with a fresh current element. Why will you start fresh? Because if your current running sum has gone negative, it's dragging you down, better to just start over. So you have two options. Two options, that is, you should make your own route or you can sit with a previous route. Okay, let's have an example of a train. If I have a train and these all elements are a businessman which has their own amounts. So I am continue with my train which I have zero amount. So when I am going through every businessman, they are putting their amount. So firstly I am coming to -2. So if -2 sits with me, then my amount should be -2. And if it starts with their own root, then also it is -2. So let's have sit with just with 0. The profit is sitting with 0. So now I have -2 with me. -2 with me. Now coming to 1. 1 has two options. Sit with -2. If it stays sit with -2, it will become -1. Or it can start its own route, that is with 1. So profitable is having a 1, not with -1. So it never go with -2, it starts its own route. So I'm starting with my own route. Okay? I'm taking like this. 1 is my route. And I'm going for -3. So -3 sits with 1, then it will become -2. And if it starts with its own root, then it is -3. So profitable is sitting with -2. I mean 1 and make -2. So it is profitable. That's why it's with 1 and become -2. Now comes to 4. 4 has two options, going with their own root or sits with -2. If it sits with -2, then it will become 2. So profit is making own root because it's 4 and 4 is profitable. So I'm making 4. Now I have 4. I have 4. Now -1. If -1 sits with 4, then it will become 3. And profit is to make 3. That's why it sits with 4 and make 3. Now 2. Add 2. If 2 sits with 3, then it becomes 5. So profit is to making 5 instead of making own root. So it will become 5 now. Now 1, profit is to become 6 instead of just going with 1. So yeah, it's making 6. Now at minus 5, at minus 5, it will become 1. So, and if it makes its own root, then it is minus 5. So profit is becoming 1. So I am sits with minus 5 sits with 6 and become 1. And now again 4, profit is sitting with 1, sorry, and it will become 5. So now in whole array, which is the highest amount? Minus 2, 1, minus 2, 4, 3, 5, 6, 6. 6 is the maximum sum. So this is the solution. It better just, that's it, just 2 variables and 1 loop. That is the code. 2 variable and 1 loop. Let's go for the coding part. Let's start with current train. So I have a current train which is empty and I have amount 0 in my current train. And I have maximum, I need a maximum which is greater. So if the array is negative, that's why I'm taking maximum is a minimum value, integer's minimum value, so that I can evaluate the maximum value. Let's take one loop from 0 to end. Now I have two options, new start, or another one is sit with current train. I have two options, new start or sit with current train. So if I new start is taking the current element, and sit with current train means sit with current train, means whatever the current train is, add the current element. Next, calculate the current train now. The current train is what? The maximum of new start, because we are finding our profit. So whatever is larger, that is profitable. And our maximum is, it is also a maximum of current train, because we need to calculate the maximum in every sum. So current train and maximum. And at the end we can return our maximum. Let's run this code. Submit the code. In 1ms runtime, it passes the all test cases. So let's talk about the time complexity also. Here at Kadane's algorithm, time complexity is big of n, because it's a linear time complexity, because it is passes through in actually. So here the time complexity is big of n because it go through with array in one pass. So we traverse the array just once, and space complexity is big of 1 because no extra data structures we use. So that is a massive improvement over the brute force, from n square to N is a optimal. This is the kind of optimizations interviewers are looking for. It's a wrap on Maximum Subarray. If this helped you, smash that like button. It genuinely helps us to grow a channel. Subscribe if you are preparing for interviews and want more DSA content like this. Drop your questions or doubts in the comments and I reply to every one of them. So in the next video, we are going to look at another classic. So make sure you hit the bell icon so you don't miss it. Until then, keep coding, keep grinding. See you in the next video. Bye-bye.